Alright students, let's take a look at LO 2-4 when we had the acceleration of the cart from the falling masses. And we're going to take a look at the two relationships that we saw, one between force and acceleration and the other between mass and acceleration. Here's the graph from the data that we collected in class. What observations can we make about the data? So one might be that it is linear. Another might be that it's almost going through the origin. So if data is linear and going through the origin, then we say that the two variables are directly proportional. So here we see that the acceleration of an object is directly proportional to the unbalanced force applied to the object. What do we mean specifically about directly proportional by that? It means when the change in one variable causes the same change in the other variable. So for example, when force is doubled, the acceleration would be doubled. When force is tripled, the acceleration is tripled. Hey, Rosie! When force is halved, the acceleration is halved. Whatever change is happening to one, the same change is happening to the other. Does our data support that? If we look more closely here, so when we had 4, let's see here, just trying to move that. Okay. Well, when we had the value of 4, it was kind of around there, about 0.6 maybe, 0.7. And when we double that to 8, we can see that the data now becomes, if I just want to move that, yeah, let me do that. Okay, well I was a little bit off. I can redraw that line, but we can see that it is pretty much doubled. 0.6 or 0.7 going up to about 1.3 or 1.4. Okay, now in this space to the right, what I wanted to do with you is to graph what the equation looks like for y equals x. So, because when y equals x, this would show that as x increases, y will increase. So if this is our x-axis and this is our y-axis, and we'll go from 0 to 5, and from 0 to 5. If x equals 1, then y would be 1. If x equals 2, then y would be 2. So 2 is 2, 1 is 1. When x is 3, y would be 3. When x is 4, y would be 4. And when x is, oops, I did that wrong. This should be 5 here, and 5 here. Okay, I think we see what's going on here. When x is 5, y will be 5. So we're seeing now, like we saw before, that we're going to have a straight line, a linear relationship. Okay, so let's take a look. Let's take a look at the second part of this, or let's see here, the bottom. When two variables are directly proportional, the slope is always, well, how can we describe this slope? We might say that the slope is positive, and it's constant since it's straight. It always goes through the origin. In our case, we saw that it didn't quite go through the origin. We had a little bit of pulling force that was required to overcome the friction that was keeping the cart from initially moving. But without any resistance, if there was no friction, it would have begun to accelerate with any applied force. it would have gone through the origin. Okay, we're going to end this, and this will be part 1, and we're going to come back for part 2 here.